Well, that's really good. I think that's something that another webinar,
Good morning.
Hi, Jason. Hi, Tommy.
Hi, Tommy.
I thought I saw a Tommy Scaff there in the
Yeah, I did.
in the
Morning.
video.
I just called Kevin earlier to let him know I ordered up some special weather for him for his trip for next week.
Yeah. But what's the temperature, Tommy?
You need to pack your socks for your flip flops because it's gonna be about 30 degrees Tuesday.
Oh no.
It's for you.
I jinxed it because last night I was telling people I can't wait. I'm going to Texas. I'm going to try to warm up for a few days.
Well, we're just wanting to make you feel at home.
I know somebody could say, "Oh, it's not the same 30. It's different down there, right?"
Right.
No, it's 30. It's 30.
No, it's a different 30.
It's a tropical 30.
That's right.
You're closer to the equator. It's got to be warmer, right?
That's right.
Right. Jason, how is it there in Oklahoma?
Well, I'm at home because the roads are icy, so we haven't rolled out yet.
Oh no. Well, it looks like we're going to be down to.
This weekend, it's supposed to be wind chill of -20 here in Oklahoma City.
Oh, great. So we're coming down there on the 23rd. So
Yeah, we should be warm by then.
Oh, I hope so. Is that a promise? Because we're awful cold here.
We'll put in for it. I'll tell you that.
Okay. Tommy didn't do a very good job in Texas for us next week.
Hey, it's only 65 degrees today here right now. Okay.
Yeah, 30 when I come. 30.
Yeah.
Yeah. Alex is going to cancel.
Now he's the one that sent me a text seeing if I could do it.
Morning, Greg.
Hey, good morning. How are you?
Real good. Good to see you. Morning, Ryan.
It's showing 19 degrees right now. It feels like 6.
Oh,
Where's that at?
Oklahoma City.
geez. I guess I never thought it got that cold over there, but it's colder there than it is here right now.
No, it's not. It is 12 degrees in Cleveland. Feels like 2.
There you go.
There you go.
There you go.
Almost for my cigar exercise this morning.
Oh.
It's 15 in Denver and feels like 6 this morning.
That's cold for Denver.
Imagine that. All this cold air across the country right now.
Mm-hmm.
As opposed to all the hot air you had on the sales call yesterday.
There's some hot air.
All right, I shall mic myself now.
Jeff, glad to have you on this morning.
Thanks. Good morning, Kevin. Good morning, Sharon.
Hi,
You
Jeff.
got Bobby. Bobby, I see you're on there too. Morning. Thanks for joining us.
Sharon, are you guys going to record this for and then archive it for later?
Yes, I'm recording it.
Okay, thank you.
Oh, I didn't know that. I'm out. I can't do this. My hair's a mess today.
Yeah, I'll second that, Kylie. Good grief.
I don't think the camera portion shows up on the recorded call. So
Oh, okay. All
You're
right.
good.
Well,
Oh, you can get away with
maybe there's a chance then.
Get away with anything.
thank you.
Yeah, usually, just so everybody knows, it usually takes till 5 after before we're pretty safe. Everybody's gotten on. A lot of people jump right on at 8 o'clock, so we'll see what we get this morning. We had 16 on the call yesterday, which was really good. So
Very good.
now the stack's up today.
Yeah.
Did anybody see where I put my coffee?
I've got mine.
Hi, George.
There it is. Hey, George. Good morning.
Morning.
Morning. Is Ryan going to be with you, George?
He is not on the site I'm on. I'm not sure. I tried calling him yesterday, did not hear back from him. He was off work, sick, I believe.
Okay.
So Eric had me send him a reminder. I'm hoping that he gets on.
Good. There's a Ryan on there. Is that Ryan Caldwell?
Yeah, that's me.
Hi, Ryan.
Hey, Ryan.
Good morning.
Hi.
Well, did anybody win any money on the Super Bowl?
Unfortunately not.
I was in bed.
We have anybody from Kansas City on here yet.
I did remarkably well. I usually never win sports bets. And I placed a bet on heads. I placed a bet on the first score being a field goal. And I placed a bet on Tampa Bay.
Nice.
All three of them paid off.
Nice. Good
It
for you.
wasn't enough for me to quit my day job, though.
Well, we'll stop up for dinner then. That's all. We'll just come up.
Yeah, please do. It makes up for all my stupid Illinois bets that I always lose.
My block pool, I swear, every quarter I had the opposite team's numbers. Every one. You know, it was the wrong sequence. Was not my day.
That's how my Super Bowl squares went last year. It was like I had really good numbers about mid-quarter, and by the end of the quarter, I was out of the money every time.
Yeah.
I'm like, okay, stay there. Be slow for a while. Nope, that didn't work.
Well, my buddy's block pool that we play cards, our card players, one guy won 3 of the quarters out of it, so including the last quarter. So he pretty much rocked it.
Nice.
I guess Tom Brady is a heck of a player, huh? Kind of proved it.
He certainly rallied the troops around him this year, that's for sure.
Hard to deny that. It's hard to deny what happened there.
Yeah.
Give it a couple more minutes, I think. Lonnie, glad you joined us.
Yeah, hello, Kevin. How are you?
Very good. Very good. Great. Here comes Daniel. Morning, Daniel.
Good morning. Good morning, everybody. Alex, Kiley.
Good morning.
That's 2 days in a row, Daniel.
That is what it is.
Our pleasure.
Can't get enough training.
All right. Good. Will Gabe be joining us?
He's supposed to be.
Good.
I guess he's, he usually shows up a little bit later to the office. That may be him, but
Okay.
he'll be on shortly.
Yeah, it's early for you guys, right? So,
It's only 4 in the morning. No biggie.
Morning, Jim. Thanks for joining.
Morning, Kevin. How are you today?
Very good, sir. Very good.
Good. I'm waiting. Mike's out at Lorraine Community College. He's can't log in on his iPad for some reason. So he's trying his phone right now. He just called me or texted me a few minutes ago. So he's trying.
Very good. Very good. It's always.
I'm here.
Go ahead, Tom.
And
Mike,
Charlie's here too.
Oh, Mike's there?
Yeah, I'm here.
Hey,
There
Mike.
you go. Good job, Michael.
Great. You were gaining. I called it earlier that it gets really busy around 8:02. It starts coming in. That's 15 people on the call so far. Trying to think who else would be expected. Greg Pop, are you on there?
Mm-mm.
Well,
Is
can't make everybody wait.
Yeah, Matt's on.
Sharon, thanks for putting this together again, coordinating all this stuff for everybody. We appreciate you putting it together. I
Absolutely.
think it's a good subject title today, and it's a great time to learn a little bit more about this tool that is the mystery tool. And so I'll just turn it over to you, Sharon. Thanks.
You're turning it over to me or to Kiley?
I'm turning it over to you. You got to introduce Kiley.
All right. Okay. Kiley, you're ready to go?
I am, yes.
All right. Well, we're happy to have Kiley with us. It's early for him this morning, so go ahead, Kiley.
All right, thanks. I'm just glad I'm not on the Pacific Coast time, so it'd be 5 a.m. in the morning, not 6 a.m. So I'm thankful for that. But I thought I would do ultrasonic inspections and training this morning. It's what was seems to be an anomaly for understanding, if you will, in the electrical detection world. So I'll cover some of that. This training presentation is what I cover with the technicians when they come to class. And I thought it would be good for the sales people that are on and everyone else to hear that as well, to reinforce why ultrasonic detection, what it gives us, and why it's important to perform that function as part of infrared detection and early warning for our customers. So really, Sharon has this presentation. She can send it out to somebody if you want it. Just contact her. That's not an issue at all. There's nothing, top secret or anything in here for anything that we want to talk about. So what is ultrasound? Really, it's hearing above our normal human range. It's our normal hearing for a human stops at around 16 kilohertz. The ultrasonic detection that we utilize is listening in what's called the ultrasonic world, which means 20 kilohertz to 100 kilohertz. So above what we can use for our normal ears for hearing electrical anomalies like arcing, tracking, and corona. This allows us to detect things that we can't hear. So that's why it's called ultrasonic. It's above our normal hearing range. We use the UltraProbe 10,000 from UE Systems. Like I said, it's listening in the 20 to 100 kilohertz range. Low frequency sounds are easy for us to hear, but if we're hearing them in that under 16 kilohertz range of audible hearing, that means the severity of an anomaly has already reached a point where replacement is probably necessary, and we can't do anything in the predictive world or the predictive realm of electrical maintenance. So we want to use this high frequency sound wave in the 20 to 100 kilohertz to detect as early as possible electrical anomalies. And I'll cover a predictive maintenance chart here in just a little bit that I want to show everybody to show us why that early detection is so important. So the ultra probe really needs at least two things for us to hear anomalies. One is turbulent flow. So it's a really good early detection for leaks. If we have leaks in vacuum system, leaks in air systems, leaks in those kinds of pressurized fluid flows, then this is an excellent early detection for that. The other thing it needs for us to be able to hear what is going on is friction. So it needs some kind of disturbance to pick up what that anomaly is doing. And those are the two things that we have to have for the ultrasonic detection to work. This is the reason why it is so good that at early detection, is that those things happen in a very high frequency, in that 20 to 100 kilohertz range, the ultra probe picks up. Then what it's called heterodyning, it changes that signal from something we can't hear to something we can hear, and converts it to a signal that we can actually do some signal analysis on with their software to figure out what it is. When you first start up, it's really hard to detect and hear what you're listening to, because it is so sensitive when you're in an electrical room or mechanical room and you're using it for some of the first times. You hear a lot of different things, so it's very difficult to distinguish, is that an issue or is it not an issue? And that's where using the detector more and more frequently becomes the norm. And it's kind of like talking to somebody for the first time on the phone, right? The first couple of times you talk to somebody, you're not familiar with their voice, so it's kind of hard to distinguish who is who. Let's take this webinar, for instance. If I talk to all you on the phone every day for a week, by the end of the week, I would know your voices without any names on the screen. And that's kind of what ultrasonic detection is. It's listening and using that device over and over again until you can start to hear what the anomalies are, and then your brain will start to ignore what else you're hearing there. That's another benefit of having the software that UE issues with this, is you can record all of those sounds and put them on their software and actually do some signal analysis that I can help you with, and we can learn to listen and train our ears to hear the arcing, tracking, and corona that might be present in electrical distribution systems, as opposed to normal background noise, normal background chatter of electrical equipment or other things in the area. So it's really good at hearing a lot of things early, like I said. So airborne really means you're listening through the air. It's also really good at structure-borne, meaning we have contact probes and other devices that we can use to listen inside of oil field transformers, oil field switches, things like that. That is one thing that we have to keep in mind when we're using the ultra probe in the field, is it is not rated for an electrical environment. So meaning it's not an insulated tool. So our technicians would never want to use a touch probe on anything that is open and energized. We would always want to do it airborne style. The structure-borne stuff is always for oil field devices where we're not exposing our technicians and electricians to anything that's energized work like that, because we'd never want to use it for detection of energized components where we could receive a shock. We don't want to create an arc flash event and have somebody get hurt. So for our technicians, I teach them that airborne ultrasonic for electrical leaks, bearings, motors, anything in the airborne realm is in that 40 kilohertz range, so they can tune the frequency of the ultrasonic probe to different frequencies based on what they are utilizing the probe for. So I teach them this in class, and for airborne, it's 40 kilohertz. That's where we like to tune it. Now, that being said, everybody's hearing is a little bit different. Everybody hears a little bit different frequency range. So you can adjust that up and down, you know, a frequency or two, you know, say 39 or 41 or 42, something like that, to better tune to your hearing and the way that your brain processes those airborne signals. But airborne is typically around 40. Structure-borne is usually 20 to 30, and then we see that bearings and mechanical, steam traps, underground, behind walls, those kinds of things all have different frequencies that are associated with that. So why is ultrasound or ultrasonic tool so important to us? It is the earliest form of detection for an anomaly. So we have the greatest amount of time from early detection to extend the life of our customers' electrical distribution equipment, regardless of what it is. So the earlier we can detect it, the better off we are for making adjustments or cleaning things or making a repair if we have a bad component or termination that we're listening to. So it is our earliest way to extend the healthy life and condition of the electrical distribution system. It is also used as a safety tool for our technicians before they open any electrical panels or cabinets or enclosures, because we can hear around all the little gaps and cracks that manufacturers build in for ventilation and listen to see if there's any kind of arcing, tracking, or corona going on in the cabinet. That early detection may be a warning sign that we don't want to open that gear if there's already a problem behind there. One of the benefits of using this tool, the UltraProbe 10,000, is that we can see the amount of turbulence that is going on behind that cover or inside the electrical equipment enclosure, and we can actually record that and tell the severity of that based on how many decibels that is. That's a technique that I use to teach the technicians for that. You know, if you have something that is really bad, it's going to put out a lot of turbulence. Therefore, you're probably not going to want to open that cover without any additional protection. Maybe go to the customer and tell them, hey, it's time to perform lockout on this and shut it down during a scheduled maintenance because we hear this behind the cover. And then they can record that sound and listen with the customer and even do signal analysis and put that on a screen for them to see, and we can break down what they've recorded. So it's a great tool, especially for our technicians to stay safe out there before we open the panels and electrical distribution covers and stuff like that to perform infrared and other visual inspections. So this is what I was talking about. This is a predictive maintenance chart. We can see on the left-hand side of the screen, everybody understands once you energize a component in an electrical distribution system, you really start its life expectancy span, right? So from the time that it's energized to the time that it fails is a given set time. The earlier we can detect an anomaly, the more we can extend that maximum time in the middle there that you see on the screen for planning, for correction, for cleaning, for adjustments, all that kind of stuff. So you see structure-borne and ultrasound is the earliest form of detection. Next is vibration. Vibration really only happens with rotating machines and equipment or fluid flow. You can detect vibration with fluid flow as well. Next is oil analysis, and then the next one after that is infrared. Well, we know not everything in an electrical distribution system is insulated with oil. So really we have two things in this predictive domain to use and utilize for our benefit to help the life and condition of our customers' distribution systems extend to the maximum we can. You can see as you get further out to the right towards failure in that fault domain, when we hear it and see it with our eyes and ears, it is already to a point that the curve is so steep, we're not going to get much life extension out of that. So using IR and ultrasonic is a way to benefit our customers. Like I said, to extend the healthy condition in life as long as we can of that equipment. So I've got a couple of sound clips to play for you. Tracking, corona, and arcing. I will say that tracking and arcing are the two that'll happen on a low voltage distribution system, meaning below 1,000 volts. Corona only happens on medium voltage and high voltage electrical distribution equipment. It takes that much force, meaning voltage pressure in a system, to create corona. And so we'll hear typically tracking and arcing on the low voltage side. And then in the medium voltage world, we can add corona to that as well. So in the medium and high voltage, we can hear all three, arcing, tracking, and corona, okay? So I'm gonna play this audio for you and let you listen to this. And this is what tracking sounds like. I'm not sure what in your minds that sounds like, but I can tell you after many years and many recordings, to me, I can hear a distinct buildup and then a distinct crackling of a release, a pop, if you will. And so to me, that almost sounds like popcorn going off. You know, you have those indirect pops, and they're not really on any kind of schedule, if you will. It's kind of random. So to me, that's automatically tracking, even if it's not played on the screen where I can read tracking as the sound, right? This is how my brain relates to that. So what tracking is electricity is building up and eating away at the insulative properties of the distribution system and making its way to ground. So tracking is exactly that. It's tracking a path from an energized component to a grounded component or a grounded surface. And so that tracking is the eating away and deterioration of the insulation between energized and ground. Now, once it reaches a path, we can get arcing. So the tracking is the eating away of that. Arcing can have tracking with it, which is what you're hearing there as well. But you hear a much more distinct, sustained release of energy, and that's exactly what arcing is. Tracking has reached a point where it can actually discharge over to a grounded surface, and that's arcing. So now we have completed a path. The next thing to build up after that in a low voltage distribution system is a direct short. So arcing and tracking are the early warning signs that we're building towards a direct short circuit to ground or phase to phase. It could be either or. So this is a great way to let a customer know, hey, we do hear something, and the eventual failure of that component is based on the severity of arcing and tracking. How close are we? How much arcing is going on? Because arcing means that the path is already built. Now we're just trying to build a constant path versus a temporary path. And once that happens, we'll have a fault condition and a short circuit, and the equipment will fail. Next, in the medium voltage world, like I said, is corona, and we can hear it. Some of you may be familiar with hearing this if you work and live around high voltage lines, overhead lines. Sometimes you can hear corona, especially when it's really foggy and cool in the morning. You can hear this on rainy days as well if the electrical distribution and transmission systems are close enough to where you can listen underneath. To me, this sounds more like an AM radio static, but what's happening is the ions are releasing particles as the air is being stressed by the voltage. So the voltage really stresses the air around it, and it is jumping off and smashing into other particles in the air, and they're releasing ions, and that's what we're hearing is the turbulence there with the corona. So those are the three things that we can detect in the electrical world. It's really good as well for doing bearing inspections, air inspections, vacuum inspections, on vacuum systems, or inspections on vacuum systems, those kinds of things as well. So there's a mechanical side to it that you could benefit customers as well. I know when I spent a lot of years in the field, that was one of the things our customers like to do when they found out we had this, is come and do air inspections. Especially with steam traps as well, so we could listen and hear and make sure steam traps were working in their facility. We could hear and make sure that they didn't have any bearings going out. We could hear air leaks. The more air leaks we repaired, the more efficient their air system became, the less that they had to pay in energy to keep compressed air into their system. So it's a great benefit and other means and methods as well inside the other than just electrical distribution inside your customers' facilities. So here's a great example of one of the inspections that I performed and we found at a facility I was working at. And you can see on the screen here, this is part of the insulative board between medium voltage phases and some medium voltage switching equipment. And we can see here where the electricity has eat up a path in the board from the white part. That's where the energized component was, and we could see where it was building up and discharging over to the board, and then the board tracked through it. And on the left-hand side is where it was actually arcing over to ground. So you can see it just made a complete path there from right to left. We can listen again if you want to any of these sounds, but the more you listen to them, the more you get familiar with them. There's not a lot of temperature difference that we can detect with the ultrasonic probe. Because this is the early warning signs of a problem in a condition in the distribution equipment, it's not made really enough of an issue yet for our infrared technology to always pick it up. So just because we can hear it doesn't mean we can see it, which is another great reason why to use the ultrasonic probe. You can see here, this is where the insulator was on the board. What had happened is the board, where it slides in between the phases, had come loose and leaned over onto the insulator, or at least that's where it started, or ended up, I should say, is over to the insulator. It didn't start out that way, but it failed when it started to break down. That also causes vibration. So we can, when we record this and play this back, you can also hear mechanical noise in that, meaning the vibration of that insulation board sitting there vibrating in that cabinet as well. So we can detect those kinds of things as well with that vibration. So you can see there, this is where it was really close and leaning now because it had failed. The support system had failed with the insulator board. Here you can see it's kind of a backed out picture. You can see where that was in the insulator system. It should look like the left-hand divider board here, okay? And you can see where this one has lost its composure, if you will, and failed to the left-hand side and got close enough now that we can hear it arcing and tracking across to the grounded surfaces. You can see with that zoomed in like that, we took that with a live camera, meaning this is not ultrasonic detection that you're hearing. This is like a video camcorder, and we recorded that sound as we were zooming in. And so that is an audible noise that you're hearing. So it is gone way past the ultrasonic early detection to a failure point. And that's why when we use the infrared camera, now we can see heat buildup in the distribution system. Okay, so this is gone to a point where we had to replace and clean the insulator and replace the insulation board and do some cleaning inside that cabinet and replace some of those insulation components between the phases. So this took an outage on the electrical distribution system in order to make this repair. But we knew if we left it and did not do anything to it, this would eventually build to an arc over potential, and we would have a phase to phase or a phase to ground short. Then that's of course extremely bad. We couldn't have saved a component then. So this medium voltage switch is upwards of $50,000 if you had to replace it and buy it new. So this is another great reason why, you know, you spend a couple of grand, you know, $2,000 on labor and equipment and clean and do some repair, and now we don't have an anomaly building up in a cabinet that's working towards a failure point. And we've saved a distribution system and an unplanned outage with that. So there's great benefits there. So I've got some other slides here. I'm not going to go through talking about Corona and what it is really, but you can see some nitrates build up on these cables. This is another anomaly that we detected on a 5 kV motor starter in a helium compressor building. And you can see that. Corona is a natural occurring thing when you have medium voltage systems. So you can have destructive and non-destructive types of corona. Destructive means that we are actually breaking down the insulation parts and pieces and doing that kind of thing where we're building up nitrates on things, and nitrates, when they get wet, makes nitric acid, and then the acid starts eating the components. So corona can be a very bad thing when you're in the medium voltage as well. Some other things that play into that when you're listening for corona is temperature and humidity. Like I said, you can hear natural corona when you are under an electrical distribution system in the cool mornings, when it's foggy, when it's raining, those kinds of things, because there's more means and methods for the air particles are closer together because it's more moist and condensed. So you can hear that a lot easier on those kinds of mornings. Ultrasound is directional. That's another benefit of early detection. We can teach the technicians, or I teach the technicians, to do what's called a gross to fine method. We start out in an electrical room and you listen to everything. You just kind of point the ultrasonic probe in all directions and listen for anything. And then as you start to hear things, you can start to work your way down to a finer path, if you will, and hone in on exactly where the anomaly is coming from. So you can move it and use it across multiple applications. All right. So I'm going to stop here for my slide presentation because the rest of it is in class stuff that we use the UltraProbe for. But I'll open the floor up for any questions that you may have.
Hey, Kiley, it's Jim from Brewer Garrett. How you doing?
I'm well. How are you, Jim?
Good, sir. Hey, we just got our Ultra probe back from UE Systems. We sent it out for calibration and all that. How often do you think we should have that done, Kiley, for servicing or calibration or whatever on the ultrasonic, the 10,000?
That's a great question. They, being UE Systems, has taught us a way to check our ultraprobes in the field that I teach the technicians for. It's called a sensitivity validation check. And we have our technicians periodically check the sensitivity validation in a manner for those probes so we can start to log how our adapters are trending on the end of the gun. In other words, are they deteriorating? Are they staying healthy and clean? And when we start to see a deterioration, then we'd want to send that ultra probe off to get maintenance done on it and calibration done on it. I believe they being ultra UE systems tells us that we should send our ultra probes off at least every other year to get cleaned and maintained.
Every other year, then I got that. And then before, like when Mike and the guys show up to a new job, they unpack it. Is there anything that they need to do right away to do a quick test and check before they actually start listening? This is when they just arrive on the job. They haven't used it since the last job. Is there something they could do to verify everything's working?
Yeah, absolutely. I always suggest that you check your equipment out, make sure your batteries are charged, all that kind of stuff the day before you're on a job, because the last thing that you want to do is show up to a customer site and your equipment not work. So I always ask the technicians to make sure the batteries are charged, make sure the memory cards and stuff are cleaned off and ready to go, and make sure that they've done their sensitivity validation the day before. That way, at least you know a day before that you've got an issue, you don't have an issue, you're good to go, those kinds of things. So I would not wait to do that when I arrive at the customer's site.
Excellent.
Or
Thanks,
at least
Tommy.
that's not the best practice, I would say.
Yeah, no, I get that. But good advice, and I appreciate the answer. Thank you.
Thank you. I appreciate it. Any other questions?
I do, Kylie. And
Okay.
I hate to be me to ask this question. I should know this, but so I'm using the tool before, when you first turn it on, there are sounds you hear, right?
Absolutely.
And I think just like air leaks, you can hear all that thing. But mostly, wouldn't an air leak or even a vibration be a real consistent sound? And we're hearing a lot of popping from the tracking and arcing.
Absolutely. Think about using an air hose right in your shop or garage area to blow dirt and dust across the floor. Air leaks really sound just like that. That's easy to detect. It's a consistent noise. It sounds like air flowing out the end of a nozzle, because that's really what's happening is, you've got a leak around a thread or a failure or a fitting or something like that, and that air is just escaping. So as long as there's pressure on the system, that's a consistent, noise with the air rushing in or out, depending on if it's a vacuum system or, whatever. So yeah, that's very consistent. Where the electrical side is a little more popcornish, if you will, with random pops and crackles and those kinds of things. You would think that would be fairly easy to detect, and it is once you get familiar with the equipment. But there is so much noise in an electrical and mechanical room when you're listening to that sometimes that it's hard to distinguish. That's why another reason I always tell the technicians to take a recording and get with me and let's do some signal analysis, because we can put frequencies on that during signal analysis and tell whether that's an electrical anomaly we're listening to or whether it is a mechanical anomaly we're listening to, because the frequencies will be different. I could see 40, 50 hertz frequencies on a mechanical noise where 60 hertz is going to be the electrical, of course. So there's some things that we can do to help detect that, and that just takes practice. It takes use, and the more you use it, just like anything else, the better you're going to be at it.
Great. And so mechanical looseness is probably similar. It would have a consistent sound, because I think that's where is it?
Mechanical is all over the board. Sometimes, because some things vibrate at different frequencies. Sometimes it's consistent. Sometimes it sounds more like that random popping and stuff like that. But you can't hear the difference between 50 hertz and 60 hertz. You have to do signal analysis on that. So you have to break it down and heterodyne those signals on a computer to be able to tell us what that really is. And that's where the benefit of the software comes from.
Super. Thanks.
You bet. Any other questions? Crickets. Bueller.
You do so good. Nobody has any questions.
Well, I hope so. I hope that's the case.
I don't want to end it on
Sharon,
that
it looks
note.
like you're up again.
Does anybody have any questions real quick? So let's think about some of the takeaways we took from both parties, for sales and technical. I mean, we know now, we're very clear now today, and even though a lot of you knew this, and the electricians, that this here sounds we can't hear. This is predictive maintenance, not so much preventative maintenance. I mean, you could tie it into preventative maintenance, but it's predictive. When we're talking to our customers, when we're trying to explain the tool, we can predict a failure with this tool. And it detects anomalies before it gets to the point where it's hot. And the infrared camera shows it can detect problems prior, so a guy that thinks I'm getting a shoot and scoot in to do my infrared without the ultrasonic, by the time he gets it, it's already a problem. And we never know if a problem is going to take 10 years to creep up and bite him, or whether it's going to take 10 minutes, right? So the tool is, without the infrared, you're not really getting the best test at all. And ultrasonic is why we paired that up. Earliest form of detection. It's a safety procedure to protect the customer. By you checking that cabinet out before you just start taking covers off and listening for something that could blow up on you, right? So that's a safety tool. We use it as a safety tool, earliest form of detection. Arcing, tracking, and Corona. Anybody selling this should learn a little more about that, read about that. Corona's definitely over 1,000 volts.
If you wanted to play these sound bites for a customer, if you're a salesperson, you can go on UE's website and download a ton of different sound bite clips or files to play to a customer. They have bearings, they have air leaks, they have steam trap inspections, they have all these electrical anomalies. So you can download those. It's free. They don't charge you anything. I think they make you sign up with your email address, so they do get your email address, but it's free to do that. And I would actually encourage that quite a bit, because it's a great sales tool out there if you can show and listen with a customer to tell them what you're doing.
Does anybody have any current issues that they're having, or any current questions from a customer that we haven't covered for you to explain? Great. Well, I think Kiley's advice of just keep practicing with it. If you find a heat problem, listen closely with your ultrasonic to help yourself learn. I think that's really the benefit, is practicing with it and doing a little extra to make sure you're understanding the sound. So great job, Kiley, explaining that today.
Thank you. I appreciate everybody's attention and had some good questions there. So I appreciate everybody logging in today and being a part of our webinar. Thank you.
Yeah. Last chance, anybody?
Yeah, this is Mike, one of the electricians for BG. Can you hear me?
Mike? Yeah.
Yes, Mike. Yep.
Hi. Yeah. It's not a question, but it's more of a comment. I've noticed like Wi-Fi signal in buildings and motion sensors, whether they're wall switch or ceiling mount, cause a huge interference noise. There's no way to make that interference noise go away. You just kind of have to ignore that.
Yeah, the only way
listen to the other sounds.
go away is to use a technique where we're blocking that signal, right? So if you're hearing something, you can actually point the gun at it and tell, of course, what you're listening to. Those things are terrible in your ears for trying to listen to other things, because they it's called competing ultrasound, and they're really flushing out a lot of noise in your ear headsets as you're trying to listen. So I teach the technicians try to block that out with their body, pieces of cardboard, between them and the sound, those kinds of things. So there's some techniques to improve blocking that, but you can't just shut it off. You're right, Mike. That's a great point.
Hey, Mike, it's Greg McDonald. Can you do me a favor the next time you're in my office? Come by and scan my office for listening devices that Lou or Kevin have planted in here.
You're going to have to put a work order in on that, sir.
There may be an extra charge paid in cash.
Beer and alcohol is always an acceptable currency.
Right?
Easy, Kiley.
But one of the things that I've also noticed is that VFDs are also very noisy.
Yes, yeah, you get a lot of noise in a VFD because of the signal mode conversion that goes on. They're taking an AC signal, converting it to DC, and back to AC. So there is a lot of noise, if you will, competing with that as well. So yeah, you'll hear that kind of stuff. You can go to some places that do that have those little wall plug-in things to keep rodents and mice and all kinds of stuff out of their buildings. Those will drive you crazy. You'll have to go around and unplug those from the wall if you're in that room, because that will absolutely drive you nuts when you're in that room. So because it picks up that ultrasonic detection, that's exactly what it does, is picking up that frequency that they're driving out to mess with the rodent's nervous system and those kinds of things. So it's terrible.
Goes back to the medium voltage equipment that we can't open while it's hot. I know that there's been a sale recently this year where a customer had a bunch of medium voltage substations in the plant, and they just wanted us to go around and ultrasonic each of the pieces of equipment, even prior to de-energizing and cleaning and tightening, just to get a feel, because we couldn't open the equipment. So when you get to a place where it's medium voltage and that, this is how you test it while it's hot. Infrared's not going to do you any good. Agreed, Kylie?
Yeah, if you can't open the doors and cabinets to see with the infrared, that visible line of sight, then the only other choice you have is to use the ultrasonic probe to see if there's any anomalies inside that cabinet before you open the door during an outage situation.
And then we'll do de-energized and sell them IR windows, right? So
absolutely. It's a perfect opportunity. Also make sensors for the UE probe and the IR for early detection that you could actually permanently mount in cabinets and enclosures. So that's an option too. So if you have a customer that is thinking about, the health and condition and want to benefit from that constant monitoring, if it's a critical system, depending on where they're at, we can install sensors to do that kind of thing full time. So that's not an issue at all either.
great. Well, I'm sure most of your bosses would say, get back to work. So if anybody, please, we'll open up for another minute for any more questions. I just want to thank you all for taking the time today to learn more and to educate yourself a little more about the ultrasonic. We sure appreciate Kiley. He's available. I'm available to talk about it too. So reach out to us and use us to learn more about this tool and sell it and do a really good job with it. That's the key.
Absolutely.
Good job. So
definitely.
Thanks, Kiley.
Thank you, everyone. Appreciate it. Everybody stay safe.
Thanks, Kiley. Thanks, Kevin.
Thanks.
Yeah, thanks, Kevin.
Thank you.
You're welcome. Thank y'all.
Thanks.
Have a great day, everyone.
Thank you. You as well.